Hello, Mr. Andre.
Halo. Bentar ya. Can you hear me?
Yes, Mr.
Okay, yeah, so today we'll be continuing the physics. So, okay. So let's continue the topic yesterday, which is linear motion, right?
Okay, Mr.
Okay, so I have divided this into two categories, right? First one is linear motion with constant velocity. Constant velocity means the acceleration is 0, right? Okay. And then the second one is changing velocity. Changing velocity means the
The
acceleration.
acceleration is not 0.
Okay, yeah. But there can be two types of changing velocity. So constant acceleration or changing acceleration. Right? Both of these means changing velocity, but we will not be talking about this one because it's harder. Okay? I think for a level, we'll just be doing this one. Constant acceleration, which we already discussed, right? Okay, so the first one, linear motion with constant velocity. What is the basic formula? I think it is this one. Velocity is equal to s divided by t. What is s and t?
Velocity is speed, of course. S is displacement, while T is time.
Okay. What are the units of each of these quantities? Velocity?
Meters per second or kilometers per hour.
Okay, use SI unit, yeah.
Okay, Mr.
And then displacement
Meters
and
or
time,
kilometers. Seconds.
second, yeah. And then we can rearrange this equation to get S equals V times T, right?
Yes.
Okay, now let's see what it looks like in a graph. So again, we will be talking about graph a lot in this topic. Okay, so in this graph, it is V versus T. If it is constant velocity, then what kind of line will it result?
A horizontal line.
Okay, a horizontal line. Okay, so for example, the velocity is 4 meters per second. And okay, just for example, some car is driving at 4 meters per second for 10 seconds, for example. So if I draw a line here at t equals 10, okay, then can you guess what is the area of this one?
40.
How did you get that?
4 times 10.
Okay.
And the area is also equal to the displacement, S.
Yeah, okay. Because this is actually V times T, right?
Yes.
So S. So area under VT curve is
S.
displacement, yeah?
Yes.
Okay, then what about this one? And then, okay, let's say the velocity suddenly changes. First, it goes at 4, and then it goes at -2. This one is 5, this one is 12. What is the displacement of this motion?
Seven.
7. How did you find that?
The one above 4 times 5. The one above is 4 times 5. That is positive. The area is 4 times 5. That's positive.
This
The
one?
area below is -2 times 12 minus 5 in parentheses. So that means -2 times 7. So that is -14 because we're dealing with velocity.
Okay, so I think if you say area cannot be negative. So the area is still 14, but what is negative? The negative is the displacement. So
All
in this
right, Minister.
displacement is 20. In this case, the displacement is -14.
14. 20 plus -14 practically means 20 minus 14. And so it is 6.
So 6 meter, yeah?
Yes.
Don't forget the unit.
Okay, mister.
Okay, let me screenshot this first because your mother asked for it.
Okay, mister.
If you want to screenshot too, you can do this.
I have, mister.
Okay. Okay. Now, the next one. So another graph. This time it's not VT, but it is ST. Okay. What is a linear motion with changing velocity? No, with constant velocity looks like?
Constant velocity
Constant velocity.
up. Going diagonally up at a straight line, yes.
Okay, so something like this, yeah? So this line is linearly changing, right?
Yes.
Linearly
Yes.
changing at the same rate, right?
Hmm.
And in the previous meeting, I said that if a diagonal line like this, what is the gradient of this line?
The gradient is
Delta y divided by?
delta x.
Okay. In this case, what is delta y? What is delta x?
Delta y, delta x is practically 1 in time, 1 second.
No. Y in this case is
Oh, delta s. So x in this case is t, so it's delta t.
Okay, what is delta s over delta t?
Velocity.
Velocity, right? So in this case, the gradient of this line is the velocity.
Yes.
And in this case, because the gradient is constant throughout the line, constant gradient, so it means constant velocity as well, right?
Yes, mister.
Okay, yeah. So we have two types of graph. VT and ST, right? Okay. in VT graph, uh, uh, it's always a horizontal line, meaning constant velocity. And then up to a point, area under the graph is the displacement. Yeah, if it is above the x-axis, then it is positive displacement. If it is below, then it is negative displacement. Yeah.
Okay,
So it's
Mr.
something like that. Okay, you can screenshot this.
I've screenshotted it.
Okay. Now let's talk about the second type of motion, which is motion with constant acceleration. Motion with constant acceleration. Again, we will be seeing two kinds of graph. The first one is still the VT graph. What does the VT graph looks like for motion with constant acceleration?
It is going diagonally upward.
Okay, so like this. Yeah.
Okay, Mister.
Since this is linearly changing, so again we calculate the gradient of this line, which is n delta y divided by delta x, which is
Change in velocity divided by change in time. That is the acceleration.
okay. And then the gradient is constant, right?
Come again, Mister?
The
Yes.
gradient is constant. So again, the acceleration this time it is constant, yeah?
Okay, Mister.
And then since this is a VT graph, if I draw a line here, okay, then what is the area under this curve?
The air to calculate that area, that is V times T divided by 2.
No, not to calculate. The area under VT is the what? The displacement, right?
Mm-hmm. Okay.
It's the same as before. So it doesn't matter what kind of line this is. If it is going upward or it is just horizontal, the area under VT curve is always displacement. Yeah?
Okay, Mister.
So we can found a formula. For example, this one is called V0, initial velocity. And then this one is the time. And then this one we call Vt,
Hmm.
the velocity at time t. Then we can found the area under this curve, right? What kind of shape is that?
The area under the curve. In this case, it's a trapezoid,
Trapezoid.
and the trapezoid is displacement.
Okay, so what is the area of trapezoid?
I've never learned how to find out the area of a trapezoid.
Okay, it's 2. So if we have a trapezoid, the two parallel sides, length A and B, and then the height is t. So the area is a plus b divided by 2 times t. And then in this case, in our case, in the graph, what is a, what is b?
A is pretty much okay. B is time. A is
I don't think b is sine because the trapezoid is rotated, right?
rotating.
Rotated. Because it is rotated, then this will become the A, this is the
Oh,
B.
so the initial velocity is A and the final velocity is B.
Mm, and then T is still just T, yeah?
Okay, mister.
Okay, then we get that formula, but this area is equal to S, right?
Yes.
Okay, so we got one formula, but this is rarely used. So S, the displacement, is this one. This is the average velocity, right?
Yes.
Average velocity times time. But we can use another trick to find another formula. Because we know that A is equal to delta V divided by delta T, right?
Yes.
What is delta V?
Final velocity minus the initial velocity.
Okay, so this one. What is delta T?
Delta T. Fi- Time. Pretty
Okay.
much T. It's just T.
Okay, so we can cross multiply to get, okay, or BT is equal to VO plus AT, right? And then we can substitute this one there. If we substitute, we get S equals to VO plus AT divided by 2 times T. Or if we open the bracket, to VO plus AT divided by 2 times T, right?
Yes.
Or VO, so this is actually in parentheses, right? So we multiply, distribute, we get VO times T plus half of A times T squared, right?
Yes.
Okay, so we got this one. This is one of the most important equations in motion with constant acceleration. Yeah.
Okay, mister.
So maybe another one of the formula that is often used is this one. So all the other equation have time in it, but this one doesn't have time. It's useful for those kind of situations. Yeah. So these three, I think, are the most important equation. 1, 2, and 3. Yeah.
Okay, mister.
Okay. Screenshot it first.
I have.
Okay. Yeah. So a little bit more. This is the first graph. What about the second graph? I'm just going to draw it here. It's not much. What about the ST graph? What does it look like?
With a constant acceleration, it's curving upward.
Okay, it's curved, yeah?
Yes.
Okay, something like that. Okay then, so let's give you some questions. Okay, so this is a VT graph. Okay, so displacement and distance. Okay, what is the displacement and distance of this motion?
Okay, mister. The displacement is 72. 72 meters, mister.
72 meters. Okay, let's see. Yeah. So to find the displacement, we first look at each part one by one, right? For part A,
Yes.
the displacement. 2 plus 4 divided by 2 times 6, right?
Yes.
So it's 24. For part B, it is 4 times 4. So 16, yeah?
Yes.
For type C, 4 plus 10 divided by 2 times 4.
Wait, mister.
Hmm?
2 plus 4 is 6. 6 divided by 2 is 3. 3 times 6 is 18.
Which one?
8.
Oh, yeah, yeah. 18, yeah?
Thank you, mister.
Okay. Sorry. Okay, next C. 4 plus 10 divided by 2 times 4. 28, yeah?
Yes.
Then part D. It's just a triangle now. So half times 2 times 10. 10, yeah?
Yes.
Part E, also a triangle. Half times 2 times 6.
Is 6.
And F, also, yeah, the same.
E and F cancel each other out in displacement.
Oh, really?
Yeah.
So
In
to count the displacement,
going
which
back,
are positive, which are negative?
E
A
is
is,
negative.
B is positive, C is, D is
Positive.
also positive. E,
Wait.
E is negative, and F is also negative, right? Because everything on top of this is positive, and everything below this is negative.
Oh yeah.
So what do we get for displacement? 18 plus 16 plus 28 plus 10 minus 6 minus 6.
So it's 60. Right?
Yeah. Okay, yeah. And then what about distance?
That would mean it would be plus 6 plus 6.
Oh,
So that would mean it would be 72.
oh, really? No, I think it's not. I think it's 84.
Hmm. Okay then, mister.
I'm not
Out of
sure. Let's
10.
double check. Yeah, it's 84. Yeah. Okay, screenshot this first.
Okay, mister. I have.
Okay. Next is the next question. Acceleration at part B, D, and F. How to find that?
The acceleration in this case should be the gradient.
Okay,
The
first it.
acceleration at part B, D, and F should be the gradient. At part
Hmm,
B, it is 0. At part D, if the acceleration is negative or it is deceleration, that would be acceleration equals to 0 minus 10 divided by 2. Minus 10 divided by 2. So that is over 16
mhm.
minus 14. So that is minus 10 divided by 2.
So,
Minus 5.
okay, unit.
5 meters per second squared.
Okay. What about F?
F, the acceleration, it would be positive in this case over delta t. Delta v is 0 minus 6, or 0 plus 6. That is 6 over 20 minus 18, 2.
Okay, so
That's 3 meters per second squared.
now which part are accelerating? Which are decelerating? Which one is neither?
Accelerating is F,
Okay.
Decelerating is D.
Mm-hmm.
Neither is B. No acceleration.
Yeah, I think all of them, A, B, C, D, E, F.
Okay.
A, what about A?
Oh, A is accelerating.
Okay. C,
C is also accelerating.
E,
D is decelerating, as you know. E
E.
is also decelerating. E, yeah. And
Oh,
F, accelerating. Yeah.
okay, so what can you see from this about the shape?
Accelerating means it's going up, decelerating is down, whereas neither does not go anywhere. It's just horizontal.
Okay, what about vertical line?
Come again, mister?
What about
Oh,
vertical?
vertical? If it's vertical, then that would mean that it's accelerating
It's accelerating. I think the answer will
at
be
a
none.
crazy fast speed.
It will be none. Why is it none? Because if there is vertical line here, that means at the same time that object is
Changes-
everywhere, right?
Is what, mister?
Everywhere.
Everywhere. No, mister. This is velocity time.
Yeah, but that means it is everywhere, right? A lot of velocity. So it could be anywhere, right?
What I think is that it means it suddenly changes the velocity somehow.
Yeah, but yeah. That is a topic for another thing, I think. Yeah. Okay, so if none, then it is vertical. Okay, you can screenshot this one.
Okay, mister. I have done.
Okay. Now let's see another question. Last one for this topic. Let's say we have two cars. Car A and car B, starting at the same point. So car A moves at the velocity of 10 meter per second. Car B moves at the velocity of 20 meter per second. But car A moves 5 seconds earlier than car B. Okay. How many seconds have passed since car B moves until it passed car A? Okay, how to do this?
3 seconds?
How did you get 3?
Because as car A moves 5 seconds earlier, it gets a head start and is 50 meters ahead of car B then.
Mhm.
when car A moves forward, but sorry, 5 seconds, Mr. 5.
Okay, you get 5 seconds.
It's not like car A stopped. So in 5 seconds, it's 50 meters. So after that, car B begins moving. But
Mhm.
first, car A moves forward 10 meters in 1 second, but at the same time, car B moves forward 20 meters. So you can say that B is 10 meters closer to car A in 1 second. That
Mhm.
means now it's 40 meters. If you do the same thing again, it will be 30 meters away. And if you follow the same pattern, you'll end up having to do this 5 times and then they'll be right next to each other.
Okay, yeah. So the correct answer is 5 seconds. But that is the way to answer it if you're doing a mathematics competition. What if you're to do it in physics competition? How should you do that?
Using graphs?
No, using equation. So if car B moves until it passes car A, what do they both have the same? Passes means they both at the same point, right?
Pretty much.
Are on the same point. If they are on the same point, then they have the same distance from the starting point, right?
Yes.
Or displacement. We should say displacement. Same displacement from starting point. So in this case, I can write SA is equal to SB, right?
Mm-hmm.
Because they are the same. And how to calculate the displacement of car A? What is the formula for displacement?
Starting formula for displacement.
Hmm.
S equals to Vt minus Vo over T.
That's VT, right?
Yes.
Okay, so what is the V? The V is
Velocity.
10 meters per second. So 10 meters per second times, what is the time? You're muted.
The time is 5 seconds.
5 plus T. What is T? Because I think something like this. When T is equal 5 seconds, then car A is already ahead, right?
Yes.
And then it needs, when they actually meet here, for example, a time T has already elapsed. So from here to here is T seconds.
Mm.
So for VB equal to 20 times, this is also T seconds, right?
Yes.
So 20 times T. And then we can get 50 plus T equals to 20T. And so 50 is equal to 10T. So T is equal to
5.
by 10. 5 seconds. Yeah?
Okay, mister.
Okay. So it's okay, I think, if you want to do it that way, but it will be harder for uh, another type of question. Okay, so screenshot this first. Have you done it?
Yes, mister.
Okay. So what if I modify this a little bit? So there are still two cars, but this time car A moves at 20 and car B moves at 10. So they both start at the same time and point. Car B accelerates at a rate of 1 meter per second squared. Car A doesn't accelerate. So again, how many seconds? Since they both move until car B passes car A. How to do this?
E accelerates at 1. When car B first moves forward at the first second, it accelerates already, right, mister?
Yeah, acceleration from start.
So from the start, it's like 11 meters per second squared already, right?
No, start is 10 and then accelerating.
Ah,
So this is the initial velocity.
so at first it's like 10 meters per second the whole way, like 10 meters in 1 second, right? The first second.
No, 10 meters only at start.
So 11 meters at the first second?
No, I think you don't really get the concept of acceleration here. Okay, let's see. Okay, velocity. What I talked you about velocity earlier is actually called instantaneous velocity. Okay, if I draw
Okay.
this graph again, V and T, what does the line look like for B? It will be this, right?
Yes.
This is for car B. One is 10. And then you say that the gradient of this line is 1 because the acceleration is 1, right?
Yes.
So if I ask you, when does this car B has a velocity of 10?
At the start.
At the start. So I can ask you when, right? But can I ask you for how long? How long does car B has a velocity of 10?
A fraction of a second?
We cannot say that because this is 10 is called instantaneous velocity. So it is the velocity at some point in time, not for some duration of time. So we cannot say how long. We can say when, but we cannot ask how long because this is just instantaneous velocity. I think what you mean by velocity acceleration of 1 meter per second squared is like this. Yeah. So it's 10 for 1 second and then it goes up 1. It's 10 for 11 for 1 second and then it goes up 1. But it's not like this. It's not how acceleration works.
Okay then, mister.
So how to find that? That is the problem if you try to approach this question using the same kind of trick that you use to do math problems, because they are different. Okay?
Okay, mister.
So how to solve this? You can use the one that I told you before. If car B passes car A, what does that mean?
That means car B has reached car A.
Oh, in physics?
Same displacement.
In displacement, right? Oh,
Yes.
right. Again, in displacement. So SA is equal to SB, right?
Yes.
Let me move it a little bit to the center. Okay, what is SA?
SA is how far A has went.
What type of motion is A doing?
A constant velocity.
Okay, A is constant velocity. What about B? What type of motion?
Constant acceleration.
Okay, so they both have different formula, right? For S.
Yes.
What about SA? What is the formula for constant velocity?
SA. Mm,
It's V times T,
T.
right?
Yeah.
Then what about SB? Formula for
SB,
displacement, constant acceleration.
displacement for the constant acceleration. S equals to, basically, in this case, S equals to VO plus VT. VT.
VT.
Yes. Plus VT divided by 2 times T.
Okay, it's better not to use this one if we are not doing the graph. It's easier to use the other one. What is the other one? The most useful one. That one you have to remember.
Equals VO times T plus 1/2 times AT squared.
Okay, this is the most important equation in kinematics. I think you have to remember it. Yeah?
Okay, mister.
It's okay, you will remember it over time. I will keep reminding you every time you didn't remember it. Okay,
Thank you, mister.
okay, so if you're confused, this B, that just means it's for B. So that's why I have B in every variables. Yeah.
Yes.
Okay, so we can plug in value. VA is 20.
20.
TA we don't know. And then they move for the same amount of time, right?
Yes.
So TA is equal to TB. Let's just call it T. Yeah. So T, and then VOB is equal to
VOB, the initial velocity, 10.
TB is T. Half times AB. What is the A of B?
1 meter per second squared.
TB squared, so T squared. Okay, so we disregard the unit for now. 20T equals to 10T plus half T squared. Okay, do you know how to do this?
20 equals to 10 plus 1/2 t squared. Right,
No,
mister?
it's a quadratic equation, right?
Okay, mister.
Quadratic equation. Do you know how to solve quadratic equation? We multiply by 2 first to make it easier.
40t equals 20t plus t squared. I see, mister.
Okay, something
T
like that, right?
equals 0. Yeah.
And then we can factorize the t, right?
Yes.
So, can you guess what is t? In order for this to be 0, then I think I have teach you about this on SMC. You remember?
I believe.
So one of them needs to be 0, right? So 0 times anything is equal to 0. So if
Yeah.
t is equal to 0, then whatever this is, it will be 0. Again, using the same argument, if t minus 20 is 0, then whatever t is, it will become 0. So we have
So
two solutions.
t is 20
Equals 0 or t minus 20 equals 0,
equals
right?
0. Yes. If t equals 0, then that means in no time at all, B already teleport with A.
No. So we have to answer, right? T minus 20, t equals 20 is our answer in this case. But
Yes.
why do we have to answer, do you know?
Come again?
Why do we have to answer? What is the physical manifestation of this one?
In the second one, it took 20 seconds for B to catch up with A.
Okay, what about this one?
In the second one, the first one actually, in no time at all, B is already next to A.
So this
And
means,
well, right now, B is next to A anyway.
so this is the starting point because we start from this equation, right? What does
Mhm.
this equation mean?
The displacement of A is equal to the displacement of B. And at the start, displacement of A is 0 and displacement of B is also 0.
Oh, that's why, yeah. That's why we get to answer. So that means at 2 points in time, that the two cars are at the same point at the start and when t is equal 20. Yeah.
Okay, mister.
So if you get something like this in physics, in mathematics, usually, oh, we don't use this, right? But
Yes.
in physics, there must be some kind of meaning behind this. So it's important to be able to translate equation into what is the meaning in real life. And also, I have something in real life. What can I write in equation about that? Yeah, that is the important thing in physics.
Makes sense.
Okay, yeah. So screenshot this first.
I have.
Okay, yeah. Okay, so this is linear motion. So why do we learn about this? So we move on to the next topic. So in the beginning, before I talk about motion, I talk about we are talking about mechanics. Yeah, mechanics is the study of physical things. And there are mainly two types of mechanics. Kinematics. And what is the second one? Do you remember?
Equation of a line?
No, it's called
Linear motion? Dynamics.
Okay, so kinematics is the study of what?
the study of motion without thinking about its source.
Yeah, okay. Without its cause, right?
Yes,
Well, can you guess what is dynamics about?
the study of motion with its cause.
Study of the cause of motion.
Of the cause of motion.
So today we will dive deeper into dynamics. It is the study of the cause of motion. What is the cause of motion?
There are many causes of motion.
So ultimately, I want to ask you, what makes things moves?
A push or a pull. Forces.
Force, right?
Yes.
Okay, so we will be talking about force today. Precisely, the topic will be force and Newton's law of motion. Okay, yeah. So force. Force is the cause of motion. So it is something that cause motion. But this is not an accurate definition of force. What it actually means by causes motion is actually, wait, so it's not accurate. It is correct to some degree, but not accurate. A more accurate definition would be something that changes the velocity of an object. Okay, I think it's something like this. So anything that changes the velocity of an object is called force. What are the types of forces that you know?
Pushes and pulls.
Pushing and pulling. And then
There's also magnetism and gravity.
magnetic, gravity, what else?
Friction.
Friction. So friction including air resistance, yeah?
Yes.
That is also friction. What else?
Mm,
Spring forces.
yeah. Spring force. The
Yeah.
last one.
Okay, now another type of forces include weight. Okay, so this is where we will talk about what is mass and what is weight. Mass versus weight. So they are different.
Yes.
Before we are talking about that, so these three are called the mechanical forces, meaning they have some physical manifestation. Okay, and for these three, they are non-mechanical forces. You cannot see it. Yeah. Pushing and pulling, you can do it by yourself. Friction is also, you can do it by yourself. Spring forces, you can take a look at the spring. But magnetic forces, can you see magnetic forces? You cannot, right?
Neither can we see gravity or weight.
Okay. So gravity and weight are actually the same thing.
Pretty much, yeah.
Okay, why is that?
Because the greater your weight, the more gravity will act on you. The lower your weight, the less gravity will act on you.
Okay, what is gravity?
Gravity is how hard the Earth or any celestial body pulls on you.
Okay, so actually that is a common mistake about gravity. Gravity is not a force. Gravity is what? It is a
Type of
type
energy?
of acceleration.
Hmm.
Gravity is a type of acceleration. So what is the magnitude of gravity that you know? You know?
9.8?
Okay. 9.8 what?
9.8 meters per second. Square.
This is called the acceleration of gravity.
Yes.
So that's why gravity is a type of acceleration. Okay. Weight is the force acted on something that has mass because of the gravity, because of the acceleration of gravity. We will talk deeper about that later. Yeah. So again, what is the difference between mass and weight?
Mass is basically the amount of stuff inside you.
Okay. What about weight?
Weight is pretty much the same thing as gravity. It's how much gravity reacts with you, does something to you, pulls you.
Okay, yeah, so they are different. You can screenshot this one first.
Okay, mister. I have.
Okay.
I always screenshot, mister,
Okay.
the
Because
whole time.
I have to
My
screen.
mom is very satisfied with the physics materials you give me. She ever told me, uh, probably because the materials are above my school lessons.
Oh, okay. So she's excited when you show it to her.
Yes.
Oh, okay. Don't you think it's a little bit hard? Because when I'm your age, I don't think I learned physics yet.
Yes, it's hard, but it's exciting.
It's
It's
exciting.
something fun to learn. I like to think of it as a challenge, like a
Oh,
new level.
okay. That's good. If you're interested in physics, there are many types of physics. You should see what kind of physics that excites you the most.
Quantum physics.
Quantum physics. Okay, I think we will
Because
get
it's the craziest one.
that later, not now. Definitely not some basic physics, yeah?
Yeah.
Okay, actually, talking about quantum physics, the mechanics that I told you earlier, this is the study of physical things, right?
Yes.
There are actually two types of mechanics other than kinematics and dynamics, yeah? Classical mechanics, which we are talking about now, includes of kinematics and dynamics, and the other one. So it's called classical, but that doesn't mean that it is an old, it just means this is old theory, yeah?
Okay, mister.
It can explain most daily use physics, but it cannot explain things like super big things or super small things. What can explain that? It's the second type of mechanics,
Modern mechanics or something.
quantum mechanics.
Quantum mechanics.
Okay, so this one explains physics in smaller scale. By smaller scale, I mean atoms.
Hmm.
Atoms behave differently.
Yes, for some reason.
Atoms here. You cannot apply kinematics, for example, for these atoms. You cannot apply that. Yeah.
Very weird quantum mechanics.
You have to use quantum mechanics, not the classical mechanics that I'm going to teach you now. But for the most basic things, classical mechanics is enough,
Yes.
especially I'm taking engineering, right? In engineering, I think classical mechanics is enough. It explains most things good enough. Yeah.
Okay, mister.
Okay, so back to this one. Forces. What is the SI unit of force?
The SI unit of force is in Newton.
Newton. Hence Newton's law of motion, right? Or N. 1 Newton is equal to 1 kilogram meter per second squared. Yeah?
Yes,
This is
mister.
the MKS system. What about the CGS system?
Dyne.
Have I? Yeah, Dine. Have I told you about these two systems?
Pretty much. It's dyne centimeter per second squared, I think.
Dine. It's gram centimeter per second squared.
Right. Yes.
Yeah. Okay. So, force. Force is what kind of quantities? There are two kinds of quantities, right? Scalar and vector. What kind of
Yeah.
quantities is force?
Come again, mister?
What kind of quantities is force?
Force is vector.
Vector quantities. Vector quantity means it has two components to it, which is
Magnitude and direction.
okay, magnitude and direction. In our case, we will just be talking about one dimension direction, yeah?
Okay, mister.
So in one-dimensional direction, direction is indicated by the sign, positive or negative. Okay?
Okay, mister.
And so because force is a vector quantities, we have to take into account the direction too, right? So that's why we have something called resultant of forces. Have you heard about resultant?
The resultant is basically the net force.
Yeah, okay.
Thing that happened in the end.
Yeah, symbol is this one. This one is called sigma.
Sigma.
In mathematics, this is also used, but it indicates differently. What does it mean?
In mathematics, I have no idea.
In mathematics, it is sum.
Sum.
So in a way, we are also summing the force, but we cannot just a force with 20 Newton to the right, and then a force with 10 Newton to the left. Okay, so the resultant of force 20 plus 10. Oh, this is not
No.
correct, right?
Yes.
It's not the sum. This is the resultant. And in resultant, you have taken into account the direction because this is a vector quantities. Yeah?
Yes.
Okay. Screenshot this first. I will talk about resultant more.
Okay, mister. I screenshotted.
Okay. So, resultant. Which one important topic in forces? Basically, a combination of two or more forces, yeah?
Mm-hmm.
Since we are talking about one-dimensional force only, we will just be using that. Okay, for example, I have a box which is pulled by 3 here, also pulled by 4 here. What is the resultant of these two forces?
7.
You cannot just say 7. You have to
7 newtons to the right?
Okay. This is the same as pulling it to the right by 7, right?
Yes.
This is called the resultant of force A and B.
Mm.
Yeah. So another way to put it is that resultant. Okay, for example, I have two forces here, right? 3 and 4. If I do another force, the result that it gives is the same as if I were to do these force one by one. So that's why this is called the resultant. Yeah. Now,
Okay.
still a box, but this time someone push it 3, and then pull it 4. What is the resultant?
1 to the right.
1 to the right. Yeah. And then maybe this one is a little bit harder. I pull it to the right 3, and then I pull it to the bottom 4.
Then it will go diagonally down to the bottom by 7. Diagonally bottom right by 7.
I think it's not 7, it's 5,
Oh yeah, Pythagorean theorem,
right?
right?
Yeah, right. So
Mm.
what angle does this create? What is the magnitude of this angle?
45 degrees?
No. I think it uses something called cosine. Have you learned about this one? Trigonometry?
I've heard of cosine.
Yeah, but I think it's a little bit harder, so I will not talk about that, yeah? So this is again resultant. The resultant doesn't always have to be, oh, 3 plus 4 equals to 7. No. The principle is that the resultant gives the same result as the two forces that consist of it, yeah? Okay, it's like that. But since we are talking about one-dimensional only, we'll just be talking about the two on top, yeah? This one is
Okay.
one-dimensional, and this one is two-dimensional. We'll be talking about the one-dimensional only, yeah? This one.
Okay, mister.
Reverse. Okay, so let's talk about Newton's law of motion. Even though it is called Newton's law of motion, it actually talks about forces, yeah?
Okay, mister.
So Newton's law is what connects forces and motion, because forces causes motion, right?
Yes.
But in what way does it affect motion? To know that, we need to know Newton's law.
Second law, right, mister?
How many laws are there? Newton's law
There are
from
3.
three. Okay, so we'll talk about them one by one, yeah?
Okay, mister.
I think the first one, first law of motion. What does the first law of motion say?
An object at rest will stay at rest, and an object that is in movement will stay in movement unless acted upon by an external force.
Okay, I think that is more or less the same sentence that Newton said. So I quote on this. Newton said, an object at rest is at rest. And then an object at motion stays at motion. Yeah, but there's actually okay, a little bit of note here. The note is that no external forces
Force is applied.
acted upon. Yeah.
Okay, mister.
Okay, so this basically means that if we don't do anything to that thing, it will stay the same. Yeah.
Okay, mister.
So to write it in equation, it will be the resultant of a force is 0. Resultant of forces is 0. Okay.
Okay, mister.
Another term to describe this law is also called law of inertia. What is inertia?
Inertia is basically an object's tendency to keep doing what it's doing.
Okay. Okay, yeah. In our case, what is the inertia of most thing? Inertia is the mass. So that brings us to the second law of motion. What is the second law of motion?
Net force equals mass times acceleration.
Okay, yeah. So an object with mass m, if given a force of F, will accelerate proportionate to the mass, to the force,
Divided by the mass.
and inversely proportionate to the mass. Or yeah, in equation, sigma F is equal to, okay, actually this one. This is the first, this is the way Newton described his second law of motion. Newton write it this way, but usually, in order to make it easier for us to calculate, we write it as sigma F is equal to m times a. But this one, the first one, is the way Newton actually writes it. Yeah?
Okay, mister.
Acceleration is proportionate to the net force and inversely proportionate to the mass. So again, what does proportionate mean?
Proportionate means the thing is a multiple.
Okay, if F increase, then A increases as well, right?
Yes.
If F decreases, then
A decrease as well.
okay. And then again, what is inversely proportionate?
If M increase, then A decreases. If M decreases, then A increases.
Okay. So it is the other way around, yeah?
Mm.
So this is the second law of motion. Actually, I have to write a disclaimer here. Disclaimer. This is not correct.
Huh?
This is not correct. So this is not correct. This is not always correct. Okay.
Okay.
That we will not talk about now. Maybe next meeting if we have the time. But I should tell you that this is not always correct. Yeah. So before this one, even before this one, this equation, there's actually another equation that this originates from. This one is the correct one that applies to all situations. This one is more specific to something, but I will not talk about it now. It is enough for daily use. This one is correct for daily use. But not correct for other specific calculation. For example, when we want to talk about rockets, maybe we will talk about that later, but not now, yeah?
Okay then, mister.
Okay, screenshot this first.
I have, mister.
Okay. So the first law of motion and the second law of motion. There is the third law of motion.
By the way, mister, earlier you told me that at P6 you didn't get physics. What grade did you get physics? Mister?
7.
7. Ah. I'm
So,
going to get it at G8.
yeah?
I'm going to get it at G8.
Oh. What I'm teaching you now is actually for year 8.
Okay, mister.
Previous one, physics I learned at year 7, at grade 7 is units, measurement, things like that. So the most basic one. I already teach you about that. Right?
At G8, my school will divide things into the subjects into majors. We can pick 4 majors. I think I'm going to choose physics, chemistry, distinction maths, and business.
Oh, okay.
This
So,
time, I only get physics and chemistry a bit, but most are biology.
in grade 7, I learned physics and biology only. But there's a little bit of chemistry in my
Oh,
physics.
ah, okay, mister.
But we will not talk about chemistry. Yeah? I cannot do chemistry.
Ah, it's okay, mister.
You can ask another teacher maybe.
Mm.
Okay, yeah. So motion and forces is actually a topic for grade 8. So the third law of motion, what is it?
With every action, there is an opposite and equal reaction.
Okay. An object will give an equal amount of forces of reaction forces on opposite direction if acted upon a force F. Yeah. In equation, it will be the resultant of action forces is equal to the negative or resultant reaction forces. Or someone will actually just say A and R. A for action, R for. Okay, yeah. So what does this mean? What does the negative means?
Means it is in the opposite direction.
Okay, this means the direction, yeah?
Yes.
So positive means the same direction. And negative means
Opposite direction.
opposite direction. Okay. Screenshot again.
I have, mister.
Okay, yeah. So we have talked about the 3 Newton's law of motion. We don't have enough time to talk about. So I think we will continue this one next meeting. We will talk about the application of Newton's law of motion. Okay?
Okay, mister.
Okay, yeah. So we end this today. Bye-bye.
Thank you, mister. Bye. Take care. God bless you.